Bismillah ar-Rahman ar-Rahim. I think we discussed some of the components of the barrage, and also we discussed what is the difference between headworks and barrage, and a weir and a barrage, all right, and a weir and a hump. These all things we discussed in the previous lecture. And perhaps we already discussed the divide wall. Ye ho gayi na? And today we want to start from the fish ladder. So actually, what is fish ladder? Fish ladder is a passage. It is built along the divide wall towards the main base portion. And the main purpose of providing this fish ladder, as you know, once if we construct a barrage, then we basically construct a barrier. And when all gates are closed, then the aquatic life, fishes, etc. and other aquatic life, they cannot move across. And we must have to keep passage to maintain the ecology of the river system. And so this type of the structure is provided, and it is called as fish ladder. The velocities inside the fish ladder, velocity of flows, they are kept from 6 to 8 feet per second. And this is the picture of the fish ladder. And here this is the plan and the section of the fish ladder. So in the plan, you can see that these are baffle valves, and the water moves from like this, from the upstream to downstream. And this is the section, and these are the baffle walls, and this is the bed having certain slope, and this is the water surface profile, how the water moves. And you know, due to this velocity is a very high velocity, 6 to 8 feet per second, and there is a lot of turbulence also here, which the fishes they like. Do you know what is the favorable direction of the fishes to move? What is the favorable direction of movement of the fishes? Yes?
Yes. Against the direction of flow.
G?
Sir, against the direction of flow.
Yes. The fishes, they like to move against the current of water, against the direction of flow. It means they want to move from the downstream to upstream. Okay? And this is true for all, you know, the energetic aquatic life. They want to move against the direction of current of water. But what about the dead fishes? In which direction they have to move?
So direction of flow.
The direction of flow.
Yes, in which direction the water will take them. Okay. So that is the difference between dead and life. So the live people, they have their own standings. वो हक बात कहते हैं ना, और जो dead होते हैं वो they move with the flow. So anyway, this passage is provided as the aquatic life. It can negotiate from the downstream to upstream and vice versa. And this is necessary for the growth of the aquatic life. That's why we provide this fish ladder. And you know what I would suggest you that you must, you know, unfortunately nowadays we cannot physically visit any barrage, which is, you know, is a compulsory part of the part 2, and we have to go there and visit some barrage, but due to this COVID, so what we can do, we can visit it online. How we can visit online these barrages? For example, Ballo ki Headworks, Tonsa Barrage, Kotri Barrage, Sakhar Barrage. No, not YouTube. We can go, we can see the Google Earth, and we can reach to these locations with the Google Earth. And there you should observe where these fish ladders are provided, and go to each barrage and see that all components of the barrage, where those are available. Where are the main bays? Where are the under-sluice bays? Where is the divide wall? Is one divide wall or two divide walls? Okay. Where are the fish ladders? And similarly, where are the guide banks of the barrage? Where are the marginal bunds? etc. So you must visit these maybe 2, 3, 4 barrages of Pakistan on Google Earth. All right. Now this is one more pictorial view of the fish ladder. So this one is the upstream side. The water is flowing like that, and these are the normal bays. And this is a fish ladder which is enlarged, and the fish ladder having the slopes. So this one is the, what is this called? This figure is very similar to dog-legged staircase. Have you seen dog-legged staircase? Do you have an idea? There is one landing, one flight. Then what is this one? What we call it? In case of dog-legged stair. Hanji? This is landing, and this is next flight. It's like that. Have you studied dog-legged staircase? I think you must have drawn the plan and section of the dog-legged staircase. So this is like that. So this is the downstream side. So the fishes, they move here because they feel more turbulence here. And the fishes, then they move in this direction, and then in this direction, and then they reach upstream. So in that way, so they can cross this barrier which the human beings, they have provided. Okay, so that is the main function of the fish ladder. Now the next component of the barrage are the guide banks. Now here you can see this is the layout plan of a barrage. So this is upstream side. The flow of water is taking place in this direction. So here are the bridge piers, and what is inside bridge piers? What is inside? There would be weirs.
Yes.
Yeah, and some would be the main weirs or main bays, and rest of that would be under sluice bays. As here no divide wall is shown, so we cannot say which one are the under sluice bays. And these are the guide banks. So this is also guide bank. This is the direction of flow, this is the right guide bank, and this is the left guide bank. So what are guide bank? What is their cross section? So guide banks basically are the earthen embankments of which shape? Of trapezoidal cross section. Embankments, they have usually trapezoidal cross section, and the slope facing to water is stone pitched. So stone pitching is provided on the sloping side, which is towards the water. So that is the guide banks. So there are two guide banks in a barrage, right and left guide banks. Actually, the guide bank is a river training work. Like marginal bund is also a river training work. And river training works, these similar river training works, sometimes we also provide in other hydraulic structures, like bridges, which we built across the rivers. So you might have seen some embankments on the upstream side and on the downstream side of the bridges. But guide banks, anyway, it is the main component of the barrage. Now, what are the functions of these guide banks? To guide, its name is guide banks. So its function is to guide the river to move towards the barrage. So the water, whatever comes here, so it guides towards the barrage. Number two, to contain the river width. This would be the river width. When there are normal days and even in flood days. In flood days, there is too much discharge, but the river width will remain the same because we have provided guide banks. So these are the two major functions of the guide banks. So its width remains fixed. And then here there is basically weirs we do provide. So that is the guide banks. Now come to the marginal bunds or the flood embankments. So marginal bunds are basically flood embankments on the upstream side in continuation to guide banks. So these are the guide banks. This is the upstream side of the barrage. So these bunds are provided on the upstream side. Now these bunds are also made of earthen material, and this shape is cross-section shape is trapezoidal like this. So this is the shape of the marginal bunds or flood embankments. So the length, how this length of the marginal bunds depends on what? And the width between two marginal bunds, it depends on what? And the height of the marginal bund, it depends on what?
A flux rise in water maximum height.
Yeah. Do you know the water surface profiles, which we studied in hydraulic engineering subject?
Yes, sir.
Now, what would be the bed slope of the river where we do provide a barrage?
The mild.
Mild. It is mild. So when we provide this weir or a barrage, then does it what we call damming action on upstream?
Yes, sir. Physical depth.
Yeah, it will. Then which type of the surface profile will form on the
M1.
upstream? M1 surface profile. So there would be certain length of the M1 profile. So up to which we should provide the length of these guide bank, these marginal bunds. It should go up to how much distance? Up to
the M1.
Up to the M1 profile extends. And can you calculate that, by the way?
Yes, sir. Yes, sir.
Very easily by using step equation or by using dynamic equation or differential equation. So you can do that. Right? So once we know
Yes,
up to which the M1 profile extends, so we have to profile these marginal bonds up to that length. So it means we can compute how much should be the length of the marginal bonds. Now come to how much should be the width between the marginal bonds. How we can compute? The width of the river is a function of the discharge. As the discharge increases, the width of the river increases, and in flood days, its width becomes too much. You know, this barrage is designed on a particular value of the flood, which we call as design flood. So whatever it will be the width of the river on the design flood, we have to keep the width or the gap between these two marginal bunds. Could you follow it? Could you? How far away these two marginal bunds should be, because we have computed the length. We say that M1 profile would be here, but how much should be this? Its width should be, they should be apart equal to the width of the river on that design flood. So let's say the width of the river is from here to here. Okay. So could you follow it now? And how much should be the height of the these marginal bunds? The height of the marginal bund, you know, on the design flood, whatever should be the stage, we know that. And the height should be from riverbed level to that stage plus the freeboard, because we have to provide the freeboard. So we know that what would be the value of the stage here, what would be the level of water here on the design flood. So we have to leave certain freeboard, and that would be the height of the marginal bund. So it means the length of the river depends on the length of the M1 profile. Okay. The gap between the marginal bunds, it depends on the width of the river on the design flood. And this height of the marginal bunds, they depends on the stage which occurs at the design flood. All right. So it means all dimensions we have to compute on the design floods. Now, what are the okay? In case of marginal bunds, you know, stone pitching is not provided on any side, neither the side which is not subjected to water or the side which is subjected to water. So we don't provide any stone pitching. That is the difference between the guide banks and marginal bunds. On guide banks, their slopes, they are stone pitched, which are facing to water. But here, these are just earthen embankments. What is the shape of the embankment? Cross-section shape क्या है? Trapezoidal.
Trapezoidal.
Okay. Now, what are the functions of the marginal bunds? To contain the river width at the design flood. You know, on design flood, the river width has increased, so to contain whole water. And where it will bring? What is the next function? To converge the river water. Now it is converging and divert it towards the guide banks. So that is the two major functions of the marginal bunds. If we will not provide this marginal bund or this marginal bunds, what will happen during flood days? Water will spread up to here and then it has to pass like this. So it will you know, flow from the outer side of the guide banks, and you know the outer side of the guide banks, they are not, stone pitching is not provided over there, so this can easily scour and damage the barrage guide banks. So that's why we provide marginal bunds to contain the river flow within that and divert it towards the main barrage. So that is the function of the marginal bunds. Marginal bunds are flood embankments. So how we can define marginal bunds? You know, these are the earthen embankments which are provided on the upstream side of the barrage in continuation of guide banks. And no stone pitching is provided. These are made of earthen material, and it has two functions: to contain the river width at design flood, and number two, to converge. They are converging the water and diverting it towards the barrage. So that is the function of the marginal bunds. Shall we move ahead? आगे चलें? And if you have any questions, you are welcome. Okay. Head regulator of main canal. You can see here on the left side, this is the layout plan of a barrage. This is the upstream side. The river is flowing in this direction, and here weirs are provided. These are the under sluice bays. This is also under sluice bays. This is divide wall. This is another divide wall. This is one fish ladder. On which side is it provided? Along the divide wall towards the main base side. And this is another fish ladder. So this is the divide wall, and it is provided here. Okay, this one is the silt pocket. And this is the head regulator of main canal. This is the head regulator of the main canal. So what is the regulator? Actually, regulator means a device, a structure which controls the flow of water. That is called as a regulator. Like we say regulator, fan regulator. So these regulators constructed at the off-taking points are called regulators. So this is off-taking point of a canal, and this is the off-taking point of main canal. So that's why this is called as head regulator of the main canal. If from main canal we are off-taking a branch canal, then here we have to provide a regulator, and that would call head regulator of the branch canal. Okay, and if we are taking a distributary from the branch canal, then the regulator provided at the head of the distributary is called as what we call it, head regulator of distributary. Okay, this is distributary head regulator. So that is the head regulator of the main canal, of the branch canal, of the distributary, of the minor. Now, what are their functions? They have the three important functions. The first function is they regulate the discharge towards the canal. Regulate means they control. So whenever they want to stop, they can stop. When they want to reduce, they can reduce. All right. So that means that is the first function. What is the second function? You know, these regulators, these head regulators, they control the entry of silt into the canal. How they control the entry of silt, that we will discuss just now. Now, what is the third? What is the third function of the head regulator of main canal or head regulator of any canal? That is, they can measure discharge. So they can serve as a meter. So how much is the discharge taking place or passing through the head regulator of the main canal? Now, if I take a section here, so this is the section of the head regulator of the main canal. So this one is the river, and here you can see these are the silt excluders. Actually, these are the tunnels which we provide in the barrage, and this is the slab of the tunnels, and you know, the heavy sediment water passes through these tunnels. And if you will see, this is the crest of the head regulator of the main canal, and then this is the downstream glacis, and this is the downstream flow. And again, we have to provide these sheet piles. This is the upstream sheet pile, intermediate sheet pile, and downstream sheet pile. and here there are gates. So can you see here that the crest of the head regulator of main canal is kept on a higher location, as the sediments, the sediment concentration is more on lower part of the flow, and the upper part of the water, it contains less sediments. So the purpose is, as less sediment water should enter here, and this is the how the flow takes place. So which type of flow would be this? Subcritical or supercritical, where my cursor is at right now?
Supercritical.
Yes, because the bed slope is too high. So that's why it is supercritical flow. And then here the bed slope is very less. So here there would be subcritical flow. And what should happen when the supercritical flow changes into subcritical flow? Hydraulic jump has to form. So this is the hydraulic jump which is forming here. So this is the head regulator of the main canal. Now, do you have any questions? Shall we move ahead?
Yes, sir.
Okay. Now, site selection for a barrage. For example, if we are exploring a better site where a barrage should be constructed, what are the main points we must consider for it? Number one, site must have a good command over the area to be irrigated. What do you mean by good command? The difference of level. After constructing the barrage, we get a certain pond level, and the area to be irrigated should be lower, as the water we can supply by gravity flow. So that means command. Now, what is the next? Site must be closer to the command area. Could you follow it? What do you mean by that? Suppose it's a river moving like that. This is a river, and this is the area which we want to irrigate. All right. So the site must be closer to the command area. Where I should provide barrage? Here or here? Which side would be better? This is side number one. This is the number two.
So site number 2.
Site number two. It should be closer. What would be the benefit? The benefit will there would be less seepage, less evaporation losses, less seepage losses within the canal network. Okay. Number three, the width of the river at the site should preferably be minimum, where for example, here and here, where the width is lesser. So we have also to see that. Number four, site must have a well-defined and stable river approach. The river approach, the river cross-section should be stable over there. Number five, a good land approach to the site. I mean, if this is the barrage site we are proposing, so there should be some existing road network, maybe kachar pakka. Later on, we can make it metalled road, but that means the approach. But sometimes it is not necessary that the road should go up to this is not possible that road will go exactly up to the site, because the site maybe at that time is a very, remote area, and the people, they are not living over there. What is the next? Number six, easy diversion of the river after construction. For example, if the river is coming like this, and maybe here there is a bend, then we can select this site for the barrage. And we will construct barrage in dry conditions. And when the barrage is completed, then we connect, when we divert water instead of moving from here towards the barrage. So it is talking about easy diversion of the river after construction. Number 7, existence of central approach to the barrage after diversion. This is essentially required for silt control. We should try that here the river should move straight. Number 8, the barrage site should be situated either in the number 1, sub-mountainous or boulder stage, and number 2, trough or alluvial stage of the river. You know, in case of the rivers, there are 4 stages. First stage is mountainous stage. It has very high slopes of the river. The second stage is sub-mountainous stage or boulder stage. The third stage is trough or alluvial stage. And the fourth stage is deltic stage. So out of these 4, the barrage sites are suitable for sub-mountainous and trough or alluvial stage. Like in case of Indus River, what is our first barrage? What is the name of our first barrage? Is it Jinnah Barrage?
Yes, sir. I guess
There is one more barrage. That is the Ghazi Barrage.
power के लिए.
But we take canals. You know,
Okay, sir.
power channel आ रहा है ना?
Yes, sir.
तो barrage ही बना के निकाला है ना?
Definitely.
So the first barrage on Indus is basically Ghazi Barrage, then Jinnah. तो वो कौन सी stage में है? These are in sub-mountainous or boulder stage. What about the Sakhar Barrage and Kotri Barrage? Kotri is the last barrage, and that is in trough or alluvial stage. है ना? Number 9, the river reach should be straight so that velocities should be uniform over the cross section. So these are the main 10 points which we should consider while selecting a site for a barrage. Now we want to discuss some basic things about the layout of a barrage. And you can see in this figure, this one, what are these, by the way? What are these? These two thick lines like hockey. Huh? What are these? These are the guide banks. If the direction of flow is this, then this is the right guide bank, this is the left guide bank. Okay, now we want to study what is the khadir. What is the khadir of a river? Kyun ji?
No idea, sir.
Khadir means the flood plain of a river. You know, a river in flood days, it expands up to certain limits. Those limits are called as khadir width of the river, and this width is called as khadir width of the river. For example, if in this river the water goes up to these during the floods, these are the limits up to which the water goes. So from here to here, this is called as khadir width of the river. Okay, and you know this khadir width of the river may be 15 to 20 times more as the width of the river, because in flood days it goes. In normal days, whatever is the width of the river, maybe 15 to 20 times more. And you know, sometimes river meanders like this, and then the whatever is the width of the river is 15 to 20 times more, maybe the Khadir width. What is the Khadir axis? So it is an imaginary line passing through the center of the banks, high banks, two high banks. You know, this is one high bank of the river. It is the another high bank of the river. And if I draw the center line like this, so that is the Khadir axis. Okay. And what is the barrage axis? Barrage axis is a straight line along which the crest of the barrage is laid. For example, this line, if we are providing here the weirs, main base and undersluice base, and this is the center line of the weir crests, then this axis is called as barrage axis. Now then, after barrages, what is the headwork axis? Headwork axis is the line perpendicular to the barrage axis. Okay, so this one is the barrage axis, BA, and on 90 of this, sorry, this one, I am sorry, not this one, up to here. So this axis is headwork axis. This is the headwork axis. And one thing is left. What is the river axis? River axis basically is a line parallel to the Khadir axis, but at the center of the barrage. This is the center point, and then this line is called as the river axis. This one. Okay. So I think now you could understood the basics of the river of the barrage layout and several axes or lines. Do you have any question?
एक्सक्यूज मी सर.
Yes.
सर ऐसी जगह पे फिर हमारी विड्थ क्या होगी उसकी मार्जिनल बंस की?
The width of the marginal bunds, as we already discussed, that we don't design a barrage on maybe 5,000 year return period flood. So what we are expecting that flood, that it has to repeat maybe after 5,000 years, roughly. Okay. So we design a barrage on a smaller return period, maybe 100-year return period. So whatever would be the width of the river on 100-year return period flood, so we will provide over marginal bunds that much at that much apart. Okay. Could you get
All
it?
right, sir. Yes, sir.
So we have not to make any hydraulic structure safe to all type of floods. That would be very expensive. So we don't provide that. So there is a compromises has been made between the life of the structure and the its importance, and then we decide the return period on which it should be designed. Now the guideline given by IRI Lahore for siting a barrage. So they have carried out research. IRI means Irrigation Research Institute of Punjab Irrigation Department. So these are the findings of the IRI. Now they say that where angle between the headwork axis and the river axis exceeds 10 degrees. Now you see this one is the headwork axis. What is headwork axis? The line perpendicular to this barrage axis. Okay. And if this angle which is if this angle is greater than 10 degrees, then III says that there are problems. What problems that we want to discuss just now? So when the angle between headwork exit and river exit exceeds 10 degrees, the problem of concentration of flow on one side and island formation within the guide banks arises. So what is the ideal condition? What should be the relationship between headwork access and river access? Kumaji, those should be, how much should be the angle between them? Ideally.
तो 0 degree होना चाहिए.
Yes, it should be 0 degree. So the headwork axis and the river axis both should be. What is the difference between river axis and Khader axis? Khader axis is the center line of the extreme boundary of the river in flood days. And river axis is parallel to the Khader axis, but it joins the center of the barrage. Okay. Now, what are the examples of these problems where the angle between the headwork exit and river axis, they were more than 10 degrees, like Islam Barrage, Sidnai Barrage, and Balloki Barrage, or Balloki Headworks. Okay. Now, what is the second findings? They say that if the river axis is to the right of the headwork axis, the concentration of flow is generally on the left side. All right, so it depends. So if the river axis is on right side, concentration of flow would be on left side, and vice versa. And tendency to form islands is on the right side. On which side the river axis would be? The islands will form on that side. Number 3, when the barrage is located below the confluence of two rivers, confluence means where the two rivers are meeting, it should be located sufficiently far below confluence. For example, where is some space? For example, this is one river and this is the another tributary. And what is this point? ये कौन सा point है? This is the confluence point of the two rivers. So don't provide barrage here immediately below it. Provide sufficiently below it. So the section 2 is better for providing a barrage. Number 4. The barrage should be located as far as possible in the center of the floodplain. This is the floodplain, so we should provide in the center. Asymmetry of location increases the likelihood of shoals forming. Shoal means islands, bars, and requires expensive training works. Protective measures, we require expensive protective measures. Could you follow this?
Yes, sir.
For example, this is a river cross section. I am just like this. So I think this is the center. So barrage should be provided here. Okay. We should provide barrage in the central part. We should not provide barrage from here to here. Not on one side, but we should provide in the middle portion. Could you now follow, I think? Okay. If we will provide like this on one side, then there would be shoal formation. There would be islands will develop here. What is the number 5? The most suitable site for barrage when constructed on dry land is below the outer side of the bend which is followed by a straight river reach, as we have seen here, in this diagram. So with that, we have finished this chapter. So if you have any questions, you are welcome. Otherwise, we would like to take 10-minute rest and then we will continue. Do you have any questions? So in this chapter, we discuss about the basics of the barrage. What are the main components of the barrage? What are their functions? Okay, what is a barrage? etc. So just the basics of the barrage we have tried to learn. Any questions?
So can you please repeat the difference between canal head regulator and distributary head regulator?
Yes. Okay, I would select a pen, huh? This is a pen. The name of this regulator is main canal head regulator. We always say head regulator because head regulator means it is provided on the head of a canal. Okay, so this is the main canal. That's why this is canal. This is called as head regulator of main canal. Now I am off taking this one. What is this one? What canal it should be?
Distributory canal.
Canal? This usually is it is branch canal. This is the main canal, then it is branch canal. Now a regulator provided on the head of the branch canal, this is called as head regulator of branch canal या branch canal head regulator. Huh? Yeah, head regulator of, instead of main canal, we have to say branch canal. Now, this is, sorry, I do not have space on this side. What I will do, maybe this canal is a distributary canal. And this is the head of the distributary. And we have to provide a regulator here to take water from this branch canal into distributary canal. So what is the name of this regulator? This is also head regulator, but this is the head regulator of distributary canal. Okay, and
right,
then
sir.
from here we will take minor, है ना? और ये एक इसको हम यहाँ पे क्या देंगे? We will provide a regulator, and that would call as head regulator of minor. Is it clear?
Clear,
Any
sir.
other question? Any other question? So shall we stop and take how much 10-minute rest? So now it is 8:56, so we will be back inshallah